Hello everyone, my name is Ahmed Kazim and I will be informing the viewers about cognitive radio. To begin with, I have a brief overview of the table of contents which goes over the introduction, architecture, techniques, functions, advantages. There will be a short video for a minute and a half, the impacts and ethical issues. Going over the introduction, cognitive radio is a form of wireless communication in which a transceiver can detect which communication channels are in use and which are not. This is all done in the sense of avoiding the occupied channels. These abilities help optimize the use of the available radio frequency spectrum, it increases spectrum efficiency, and it improves the quality of service for the users. So in cognitive radio, there are two main types, the heterogeneous and the spectrum sharing. In heterogeneous, operators run several radio access networks using the same or different radio access technology. For heterogeneous, it uses a network-centric approach and the frequency bands allocated to the various RANs are fixed. Moving on to spectrum sharing, several RANs share the same frequency band and they also coordinate with each other to use the unoccupied subbands optimally. In both of the cognitive radio types, radio resources are optimized and the quality of service is much better than it would be with a normal traditional radio. In the sense of the characteristics, there are three main characteristics, which is the cognitive capability, which is the ability of cognitive radio to sense the radio environment by capturing variations and avoiding the interferences around them. The second one is reconfigurability, which enables the cognitive radio to dynamically change the operating parameters according to the radio environment it is currently in. And the last one, which is learning, the cognitive radio can also learn from the experience and try out different and new configurations in different environments. In the sense of an architecture, so there is a small figure over here for the overview of the architecture. To speak about cognitive engine, it establishes a connection among the SDR transceiver, the adaptive protocol, the wireless application, and services. It also tries to discover a solution depending on the inputs. For the adaptive protocols, they are aware of the variations in the cognitive radio environment and it focuses on the traffic activity of the primary users as well as the transmission requirements for the secondary users. For the layered cognitive radio architecture, the first one is the physical layer, which can also be called the SCR. The primary function of the physical layer is spectrum sensing, and it includes functionalities like detecting spectrum holes and estimating opportunities and estimating the interference at the primary receiver. And in the MAC layer, the faultiness of spectrum sensing is checked, and in the basis, a result is taken based on whether the transmission should be carried out or should not be carried out. It also considers the process of utilizing these spectrum holes, what modulation techniques to use, what power level to use, and how to share the spectrum with other cognitive radios. This layer obtains information on the channel occupancy and it makes decisions on spectrum access and synchronizes transmission parameters. In the network layer, the primary function of the network layer is constructing topology, addressing, and routing. In the transport layer, the transport layer protocol is in charge of the flow and the congestion control, and its performance is influenced by the performance of the MAC layer. The, the final layer, which is the application layer, it is the layer which is closest to the end user and it is responsible for calculating the resources available, synchronizing communication, and identifying communication devices. Moving on to the cognitive radio techniques, in in the spectrum sensing sense, the spectrum bands in the area are tracked by the cognitive radio devices to identify users who are licensed to operate in that band, and they also search for spectrum holes, which are the unused portions of the RF spectrum, and these holes are dynamically made and erased, so they do not require a license to use. For Spectrum database, the FCC maintains a database where the TV stations update their use of the RF spectrum for a certain given time, and the cognitive radio devices may use this database to get information about the available spectrum, and it eliminates the need for complicated sensing techniques. Moving on to the sense of function, The power control is used to optimize secondary users' capacity while also enforcing certain limits to just to safeguard the primary users. In the function of spectrum sensing, it is an empty spectrum that can be detected by a cognitive radio without creating any disturbance to the surrounding users. For null space, it's using numerous antennas, and cognitive radio can determine the principal user's null space. It can then also communicate within this null space, creating less interference to the primary users. And last but not least, the spectrum management. It is when the cognitive radio utilizes the optimum spectrum available to satisfy the communication needs. Moving on to the advantages. So the space availability for new technologies, the unused bands can be used by the new technologies, which will minimize the cost when it is utilized. Spectrum is used by the unlicensed user. The efficient utilization of frequency spectrum is when the band cannot it's when the spectrum band cannot be increased, my apologies. When the spectrum band cannot be increased, but it can be used efficiently. For the ability of using several channels, unlike traditional radio networks, the cognitive radio allows you to utilize multiple channels, which reduces the chances of collision and also increases communication quality and decreases interference. For the sense of financial benefits, those users who are unable to purchase a spectrum can lease one from a license holder at a reduced fee. I have a brief video
The
to
rise in
introduce.
popularity of cognitive radio networks, both in the industry and academia, makes them one of the key enablers for 5G networks. Currently, the radio spectrum is allocated to different wireless technologies. While the frequency spectrum in certain frequency bands, like that of GSM, is crowded, other frequency bands, like that of the military, are hardly used at all, resulting in spectral inefficiency. An increasing number of mobile devices and the limited availability of radio spectrum is making it difficult for existing wireless technologies to survive in today's world. Cognitive radio aims to solve the problem of spectrum scarcity by enabling opportunistic use of the radio spectrum. With cognitive radio, unlicensed users can use licensed bands from users who are not currently using their allocated frequency. This increases the spectral efficiency. The use of software-defined radios, or SDRs, allows cognitive radio systems to adapt dynamically to the changes in their operating environments. These systems thrive on an understanding by building methodology. Cognitive radio provides spectral efficiency, operational flexibility, adaptability according to the environment, and interoperability between existing wireless networks.
That is the end of the short video. So moving on to the ethical and professional issues. In the sense of the hardware issues, the design process of the hardware for the cognitive radio is the main difficult task. The hardware must be dynamic, which should respond to changes in the environment, and there are few but major constraints to it, which are computational power, storage, and energy. In the sense of fault tolerance, it is one of the challenging problems in cognitive radio because it is designed that CR does not have the capacity to tolerate any fault. For high manufacturing costs, it's another issue for CR wireless network in comparison to the other networks available, which requires less memory and computation, and as a result, it can reduce manufacturing costs and production must be developed. So for the selection of channel, the channel for sending data and communicating in the CR is not fixed, which may result in the lack of cooperation among the nodes. In the sense of security, the CR is also vulnerable in various privacy and security issues that traditional radio attackers can gain access to the sensors and steal the sensitive data. I would like to end it in a sense that users will have access to more spectrum frequencies in CR as a result of the CR network software defined capabilities, which results in the improved communication opportunities. And in that sense, I will end my presentation about cognitive radios, and I hope you all enjoyed, and I hope it was an informative presentation. Thank you.